Hey guys, in this video we're going to be talking about how to simplify radicals, specifically referring to simplifying square roots. So if you look at this screen, we right now have a square root here. We have the square root of 32, and I want to simplify this. Now the reason I have to simplify this is because if I type in the square root of 32 in your calculator, the answer you get is a decimal. And that is because 32 is not a perfect square. So there is no whole number that's the answer to this square root. Now, when you take the square root of numbers that aren't perfect squares, you end up with a repeating decimal. So if you type it in your calculator, you probably have like 8 decimal points listed after the whole number. Um, when you see that, that's pretty much indicating that this is a repeating decimal. It doesn't actually end after those 8 decimal places. That's just all that the calculator can display. And so if you want an exact answer, you actually have to leave this in radical form, which means that your final answer will still have a square root symbol in it. And this is a really important skill that you will use as you move into more advanced math courses. Okay. So in order to do this, we basically have to break this number 32 into two of its factors. So a factor is one of the numbers that can multiply to get to 32. So let's think of some pairs of factors for 32. So I could multiply 1 times 32 to get 32. That means that 1 and 32 are factors of 32. Okay. I could also multiply 2 times 16 to get to 32. That means that 2 and 16 are factors of 32. Okay. And then I could keep going. 3 isn't a factor because you can't divide 32 by 3, or you can, but you get a decimal answer. Let's think. Can I divide this by 4? Yep, since it's divisible by 4, that means that 4 times 8 adds up to 32. 32 is not divisible by 5. It's not divisible by 6, not divisible by 7. Oh, it's divisible by 8. Oh, when I get back to 8, I have 8 times 4. That gives me 32. So I can keep working up through the numbers, but at this point, I'm just going to eventually find repeats of all of these sets of factors. So basically, there are 3 sets of factors that multiply to 32. 1 times 32, 2 times 16, or 4 times 8. When we are simplifying radical, basically what we want to do is we want to break it into the 2 factors where where one of them is a perfect square. And you'd like to do it with the biggest perfect square possible. So in this case, the set of factors with the biggest perfect square is 2 times 16. And that's because 16 is 4 squared. So I'm going to break up the square root of 32, and I'm going to rewrite that as 2 times 16. Right. Now the reason that I'd actually just would prefer to write it as 16 times 2 because it sometimes can be easier to manage if you write the perfect square first. So I'm going to write this as the square root of 16 times 2. From here, I can go ahead and break this up further. So the square root of 16 times 2 is the same as the square root of 16 times the square root of 2. And when I've broken apart the radical like this, now I can evaluate the square root of 16 because I know that that is equal to 4, and then I can leave the square root of 2 as is. And this comes out to 4 times the square root of 2. And this is the simplified version of the square root of 32. If you were to type both of those in the calculator, they would come out as the same thing. Right? They are equivalent expressions. Now, I also want to show you what would happen had I chosen, for instance, 4 times 8 as my 2 factors, because with 4 times 8, you do still have an example where 4 is a perfect square. So if I turned the square root of 32 into 4 times 8, what would happen is I can break this into root 4 times root 8, and that would give me 2 times the square root of 8. But since I didn't pick the biggest perfect square factor, now I would have to break this apart again to get me into simplest form. And I would have to turn this into 2 times the root of 4 times 2, which would leave me with 2 times 2 times root 2, or 4 root 2. So I know I went through that kind of fast, but in essence, the reason I'm showing you this is that you'll get the same answer either way, but it takes a lot more work if you don't right off the bat pick the biggest perfect square that fits into your number. Okay. So in order to help this make more sense, I want to go through the perfect squares because knowing the perfect squares is absolutely critical in order to be able to solve these problems effectively. So let's start with 1 squared. If I start with the number 1 and I square it, I'm going to end up with an answer of 1 because 1 squared is equal to 1. Okay? And I'm just going to sort of go through this list. Just like 1 squared equals 1, 2 squared is equal to 4. Just remember that all a squared is, when I take an exponent and I square something, I'm just multiplying it times itself. So since 2 times 2 is 4, 2 squared is 4. 3 squared, since that's 3 times 3, that gives me 9. 4 squared, that gives me 16. And I'm just going to keep kind of writing through this list of all the perfect squares I know. If you don't know these by heart already, I would highly recommend maybe taking some time to sort of memorize these because that will help you a lot in the future to be able to just really quickly write down a list of all the perfect squares. Okay? And not all the perfect squares, right? Because that's an infinite list, but at least through maybe 100, which would be 10 squared, it'd be good to be able to write down that list so that you just sort of have these in the back of your brain to grab from. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 are the first 10 perfect squares. And these are going to be things that we need to know in order to keep moving forward. So on this slide, I've gone ahead and I've copied down part of that list, remembering that the important part here for me to remember is these numbers here are my perfect squares. So my goal here is to break 8 apart into 2 numbers where one of them is the biggest perfect square that factors into 8. So as I do this, basically what I'm going to do is I'm going to look at the number 8. So the number 8 is smaller than the number 9. So I can ignore any numbers below 9. I'm only looking at the numbers above it. Now, every single number is divisible by 1. So I'm not really going to worry about 1. 1 doesn't really help me. So in this case, I kind of have a cheat sheet. I know that it's not going to be divisible by anything bigger than it. 1 doesn't matter. So that's my hint that it's probably divisible by 4. And since 8 divided by 4 gives you 2, I know that that's going to work out for me. So I'm going to break up 8 into 4 times 2. And again, what that allows me to do is write this as the multiplication, the product of 2 radicals. Okay, and then I can take the square root of 4 as 2, multiply it times the square root of 2, and there's our answer, is 2 root 2. And at this point, I think just going through a few more examples is really going to help make this make more sense. So I'm going to go through a few more examples. And when we do this with larger numbers, you'll be better able to see how we approach these types of problems. So in this instance, I'm given the square root of 60. So I want to look for factors of 60. Okay, and I'm going to try to find the factor that is the biggest perfect square factor. So I'm going to start with the bigger numbers and see if it's divisible by any of those. Now, I know that it's never going to be divisible by anything that is more than half its size. So basically, I can already count out 36. I don't need that. Okay, but anything smaller than that is worth trying. So basically what I'm going to do is I'm going to divide 60 by 2, and I'm going to say, okay, any number smaller than 30 is worth trying. So I'm going to, if you don't know already, right, I'm going to see, does 60 divide by 25 evenly? Okay, well, no, that doesn't work out. Does 60 divide by 16 evenly? Well, if you're not sure, a good way to double check is type it in a calculator. And if you type that in the calculator, it'll come out to 3.75, and you realize, oh, no, it doesn't divide by 16, right? You can do the same thing with 9. 60 is not divisible by 9. But when I get to 4 and I try to divide 60 by 4, I get 15. So 60 is divisible by 4. And since 60 divided by 4 gives me 15, I know that 4 and 15 are my factors of 60. Okay. So I'm rewriting the square root of 60 as the square root of 4 times 16. 4 times 15. And again, the reason that these two are equivalent expressions is because 4 times 15 is the same as 60. If you multiply 4 times 15, you get 60. Okay. From there, I'm going to go ahead and break this up into 2 square roots. I'm going to write the square root of 4 times the square root of 15. And then that allows me to go in and evaluate the square root of 4, which is 2. And then the square root of 15 just sort of hangs out there. And I'm left with the simplified version of square root 60 being equal to 2 times the square root of 15. Okay. So now we're going to go through this and we're going to try to simplify the radical square root of 80. At this point, I think it might be a wise decision for you guys to go ahead and pause this video and try it on your own, unless you are still really struggling and you do feel like you need to listen to the explanation again. But once you try it on your own, you can always unpause it and then you could keep watching. So let's go ahead and attack this. Like I've said before, I'm looking for the largest perfect square that's a factor of 80. And again, I know I'm looking at any perfect square that's less than 40 because 40 is half of 80. So that works with this list, right? If I were to keep building this list and go further down, the next perfect squares in my list would be bigger than 40, so I don't have to bother looking at them. So I'm going to be looking at at 36 and smaller. If I try to divide 80 by 36, that doesn't come out evenly. 80 divided by 25, not evenly. When I get to 80 divided by 16, that does come out evenly. 80 divided by 16 is 5. So I can rewrite 80 as 5 times 16. Okay, and then I can split this into two separate radicals. Now I'm left with the square root of 5, which can't be simplified. And I know that can't be simplified because I know 16 is the greatest perfect square. So once you factor out the greatest perfect square, there's not going to be any simplification left. But I pulled out this square root of 16. That is equal to 4. So I have square root of 5 times 4. Now, this is not really standard form. Anytime I write out a radical that's multiplied by something, I write that number out first. And so I'm just going to change that order there. Right, those two are equivalent, but this is the way that we actually write it. So the square root of 80 simplifies to 4 square root of 5. All right, so we are going to look at two more examples before we go. So right now on the screen, I have the square root of 150. Now this is a bit bigger of a number. So if you look at this, you're thinking, okay, half of 150 is 75. So I really want to look at any perfect square less than 75. So if you just wrote out this list to 36, that's not enough. I want to keep writing out the list until I get a perfect square bigger than 75. So 36 is 6 squared. I'm going to write out 49 for 7 squared, 64 for 8 squared, and 81 for 9 squared. And by the time I get to 81, I realize, oh, that's bigger than half of 150, so I don't need to look at that. So I can ignore that and just look at 64 and smaller. Okay. And then I'm just going to sort of work through this. So 150 divided by 64, doesn't come out perfectly. 150 divided by 49, doesn't come out perfectly. 150 divided by 36, doesn't come out perfectly. Oh, 150 divided by 25, that does come out perfectly. That comes out to 6. So since 150 divided by 25 is 6, I can rewrite this as the root 25 of 6, 25 times 6. And then again, from this part, I just split apart those radicals. Root 25 times root 6, and the square root of 25 is 5, so that leaves me with 5 root 6. Okay. One more problem, and again, I highly recommend that you go ahead and pause this and work on it first. I will give you the one hint. You're probably going to want to extend this list of perfect squares first before you try it. Okay. Now that you've hopefully tried that on your own, let's go over it. So as I just said, you're going to want to extend this list because half of 147, well, that's 73.5. So basically, I want any perfect square less than 73.5. So again, I'm going to extend this list because at this point, I know my next couple perfect squares. And once again, just like the last one, my largest perfect square that's less than 73.5 happens to be 64. So I'm going to work through from the biggest to the smallest number, seeing which one works. So 147 divided by 64 does not come out to an even number. 147 divided by 49. Oh, it's only the second one I've tried, but that already works. If I divide 147 by 49, and if you don't know this one in your head, that's okay. It's a little bit more of a complicated one, but that's why I just sort of work through the list methodically. When you type 147 divided by 49 in your calculator, that would come out to 3. So that means that 147 is the product of 49 times 3. Okay. And then I can go ahead and break this up into my two separate square roots. And the square root of 49 is 7. So this leaves me with 7 square root of 3. Now, with that being said, we've gone through several of these examples, so hopefully you're feeling much more solid on this concept now. If you still need help, you are always free to let me know. But again, this is a concept that you will be using in the future beyond just the topic we're doing right now. So please make sure if you don't know how to do this, you do act on that and make sure you either reach out to me as your teacher or reach out to someone else and find some resources in order to help you.